Sea level varies at the local scale for a whole range of reasons, from tides, waves, different ocean currents, vertical land subsidence, a whole lot of other things. But what we're really talking about here is the large-scale, long-term, progressive, ongoing rise of the global ocean, which has been in progress since the mid-1800s. And that rise is essentially caused by the increasing thermal energy in the atmosphere and the thermal energy that's being transferred to the ocean. So it during from the mid-1800s through to nearly the end of the 20th century, most of that sea level rise was caused firstly by thermal expansion of the sea. As it gets warmer, it expands like any liquid does, and the effect is like a thermometer. If the only way it can expand is upwards, then the level rises just like a thermometer. That was a major proportion of the reason for sea level rise through most of the 20th century. The other major reason was melting of mountain glaciers, which has been in progress throughout the 20th century. Those two factors were added to by a fairly significant change in the early 1990s when the polar ice caps started contributing significantly to global sea level rise, and the rate of sea level rise increased from about 1.5 millimetres a year to about 3 millimetres a year. The melting of the Greenland ice cap was the most significant, and you can see that on this graph. This is the relative increase in the contribution of the Greenland ice cap melting to the global sea level rise that's occurred just in the last 25 years or so. Whoops, I should have clicked that before. And so this is, I've just put this up here. This is the Jacobs Haven Glacier in West Greenland. This is the fastest moving glacier feeding ice out from the Greenland ice cap. It produces about 10% of all Greenland's icebergs. So this is one of the major contributors to this expansion or this acceleration of global sea level rise during the last couple of decades. And it's also the source of it's thought to be the source of the iceberg that sank the Titanic, but it's doing a lot more now. In terms of the effect of sea level rise on coasts, now I guess the first thing I should say is that the physical effects of sea level rise on coasts are there, but they're going to be a lot more noticeable in the future. There's a concept called the time of emergence, which is the time when people start to really just be able to see the effects of different aspects of climate change. I would say that in Tasmania, the change in the bushfire regime has reached its time of emergence. To me, it's very much now in your face. Sea level rise, not quite so much. The effects aren't quite so obvious yet, but they're going to become more obvious over time. There's really three major physical effects of sea level rise on our coasts. The first, of course, is the fairly obvious increase in the frequency and extent, and also, importantly, the depth of coastal flooding. Now, coastal flooding occurs with storm surges. We've always had periodic coastal floods. These are going to progressively become more and more extensive and deeper, particularly in the more susceptible areas, such as in this area. Maryville Esplanade is a good one. It's been flooded in the past. Browns Rivulet, Snug, Lauderdale, places like that are particularly sensitive. The second category of impact is the rise in coastal groundwater tables, which is not as obvious in many places, but it's going to become significant in places like 7 Mile Beach Township, which have already had flooding where the water table has risen to the surface. That's going to become more common. And the other major impact of sea level rise on the coast is the increasing frequency of and magnitude of erosion events. As sea level rises, then waves of any given size, storms of any given size, penetrate further landwards and erode at a higher level on the beach profile or the dune profile, and cause not just flooding of the coast, but actual physical attrition of the coast by erosion. And this is an example from Roaches Beach. Now, this is actually my particular area of interest. We are actually not yet seeing very many beaches that are showing a direct response to sea level rise. Most beaches erode, always have done for 6,000 years. Beaches erode periodically. Most of our beaches are still fully recovering because there's so much sand around, and the sand comes back, as you can see in this example, where you've got an old erosion scarp, and sand after the erosion event has returned and is rebuilding the beach pretty much completely. This is still the case in most places. And more sea level is going to be required before most beaches are actually not recovering but starting to progressively recede. But there are a few places which are the exception. We've got a couple of beaches like Ocean Beach and in particular Roaches Beach, which are particularly susceptible to losing their sand and which have changed their behaviour over the 20th century. They're still very much the minority. Most of the erosion we see isn't directly attributable to sea level rise, but we are starting to see it, and we will see it in more places. And I'd better stop there.